Hi, today we will discuss the application of Bernoulli's equation and the continuity equation, and later we will discuss the hydrostatic pressure and its equation. So what is continuity equation? We know the continuity equation as rho 1 a1 v1 equal to rho 2 a2 v2. Rho is the density, a is the area, and v is the velocity. This is the continuity equation. The next equation is the Bernoulli equation, which is P plus P1 plus half rho V1 square equal to P2 plus half rho V2 square. P1 P2 is the pressure at point 1 and 2. Rho is always constant because this is the subsonic flow, and V1 V2 is the velocity at point 1 and 2. So here is the problem. We have a pipe. This is the pipe. This is the exit. This is the outlet. Okay. The area of this exit is A1. The pressure here is P1, and the velocity is V1. At the outlet, we have area as A2, and we don't know the pressure and velocity. We have to find the P2 here, or the pressure here, and it is the subsonic flow. Which means rho will be constant. So let's say we know the density here. Okay, now by applying continuity equation, we can say, as rho is constant, we can say a1 v1 equal to a2 v2. As I said, we know the a1, we know the v1, and we know the a2. We can find v2 from here. So v2 will be equal to a1 v1 by a2. Now we know the V2, and this is the subsonic flow, so we can apply the Bernoulli's equation to find the pressure P2. So from Bernoulli's equation, we have P1 we know plus half rho we know, V1 we know equal to P2 we don't know plus half rho we know plus V2 square. Okay, so from here, after solving this equation, we can find the P2 as P1 plus half rho V1 square minus half rho V2 square will be equal to P2. So this is the application of Bernoulli's equation. You should keep in mind that Bernoulli's equation applies only for the subsonic flow, for which the Mach for subsonic flow Mach number will be less than or equal to 0.3, and for supersonic flow Mach will be greater than for subsonic flow Mach will be less than Mach 1, and for supersonic flow Mach will be greater than 1. And for the application of Bernoulli's equation, we have the flow should be incompressible. So for incompressible flow, Mach will be less than or equal to 0.3, and for compressible flow Mach will be greater than 0.3. This is the incompressible flow, for which rho is constant, and for compressible flow rho will vary. So for the application of Bernoulli's equation, we have the condition that flow should be incompressible. If in the question it is given that the flow is subsonic, we can consider flow as a incompressible flow. If the fluid is a water, These conditions are for gases, or say air. For air, if the Mach number is less than or equal to 0.3, we can say flow is in compressible flow. Now let's see the hydrostatic equation, or the hydrostatic pressure equation. Let's consider a water column. So this is the water column of height dh. Let's say this height is dh, and the area of the base is dA. So let's first understand what is hydrostatic pressure. Hydrostatic pressure is the pressure developed by the weight of fluid above the point in the vicinity of a gravitational force. So let's say here is a point, and we have to find the pressure here at this point. The pressure, or the hydrostatic pressure here will be the result of the weight of the water or the fluid above this point, which is has the height dh. So the weight of the water column above this point will be mass will be equal to rho into volume, density into volume, equal to rho into dA into dh. So this is the mass. For weight, we have weight equal to mass into gravitational acceleration, mg, equal to rho into dA into dh into g. So this is the weight. So weight is the force. Now we want pressure. Pressure we know is equal to force upon area. So here pressure at point, let's say this is the point A. So pressure at point A will be equal to force at point A, that is mg, that is rho into dA into dh into g. So we have rho into dA into dh into g divided by area. Which area? Area of the base. So area of base is a dA. So dA cancel, we get PA, hydrostatic pressure, equal to rho into dh into g. So what is P hydrostatic pressure? Is the multiplication, the product of a rho into the height of the fluid column, that is dh, into the gravitational acceleration. We should know that the g, gravitational acceleration, changes with the height, but for small height dh, we can say we can consider g as a constant, and at the surface of earth we can use g is equal to 9.81. So this is it. Let's revise it. Hydrostatic pressure, this is the water column, and this is the height of water column dh, this is the area of water column. Actually for hydrostatic pressure we don't need the area, because it will get cancelled. So we just need the dh and the gravitational acceleration. So we have mass equal to density into volume. So here mass equal to density into what is volume. Volume is dA into dh. So weight is mg, equal to rho into dA into dh into g. Pressure is equal to force by area. So here pressure at point A will be force divided by area. So dA gets cancelled, we get the PA equal to rho dHg. Also we can write it as rho g dh. So this is the hydrostatic pressure. Thank you.